Hear me? Oh yeah, there we go. That's nice. Thank you everybody for being here. I really appreciate it. If you don't mind, I'm going to sit. There's a podium here, but it's a bit at an angle. Makes it very hard to type, and typing is hard enough, I figure, so I don't want to do it at a 45-degree angle. Look, I'm so happy to see you all here today. What a privilege, what a pleasure for me to be in this beautiful city, in this beautiful place, in this beautiful space with you all today. For those of you on my left, can you even see me? I don't know. You're not missing anything. It's okay, but there's a podium in the way. Look, no, it's... oh, hi. Wait, I got to do the fish, right? Is that... They're measuring fish? Okay, there you go. I'm really excited to be here. I really am. I was deliberating, what was I going to be able to show you today to better demonstrate all the cool stuff that we're excited about and that we're working on. And I confess I had a lot of trouble kind of coming to grips with this. I thought, well, gosh, maybe we could look at the old Spring Pet Clinic. How many of you have ever used the old Spring Pet Clinic sample application here? Spring Pet Clinic. It's been around for like 20 years, 20-odd years, and it's a demonstration of a lot of different things. I mean, obviously, we've updated the code, right? It's not just it's not the same thing for 20 years, and it's so popular, in fact, that there's even a whole separate GitHub organization called the Spring Pet Clinic community. You've got AI, you've got Kotlin, you've got REST, you've got Angular, you've got microservices, you've got React, you've got Vaadin, you've got, what else do you have? You have Kotlin and REST and Angular and microservices, React, Vaadin Flow, Istio. You've got all this other stuff here, you know? And I thought we could look at that. That might be kind of fun. But then I thought, you know, it's old and there's just too many moving parts. And I wanted to have something in the same spirit, but something that we could start from scratch. And I like the idea of pets. I love pets. I love animals. I love dogs and cats and all these other wonderful critters. And I love dogs, you know. And who doesn't love dogs? You know, everybody loves dogs. I love dogs. I love dogs. I just don't love my dog. Okay, my dog's terrible. My dog's name is Peanut. He's not good. Just a terrible dog. He's like this big, but he's pure evil, right? So, he's not a good. He causes an unusual amount of angst and terror in my home. You might wonder, well, why do we keep him? Well, there's three simple reasons, right? And I'll be honest with you here. Obviously, the very first reason, of course, is because, you know, even terrible dogs like Peanut deserve loving homes, and so that's obvious. Number two is ego. Ego is very, I'm a little embarrassed here, but it's true, okay? It's ego. And what I mean by that is, in my home, my partner and my daughter both speak 5 languages. I only speak 3.5. So if we didn't have that stupid dog, then I would be the stupidest in the house. That cannot stand. It cannot stand. So we keep the dog for this reason. And then the third, and I think most sort of superficially obvious reason is that, well, you know, he is just very cute. He's cute. He's very cute, but also evil, pure malevolence. You know, not a good dog. You know, just very cute. The best way to experience Peanut is in a photo in another continent, as we are doing right now, right? So yeah, not a good dog. He reminds me of another dog about which I learned during the pandemic. This dog's name is Prancer. Prancer, not a good dog at all. This is an ad that this woman had put out to find a new home for this dog. And she said, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is, there's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. She says, this dog is literally the Chihuahua meme that describes them as being 50% hate and 50% tremble. She said that this dog wants to be your only child. She says that this dog is not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. Yeah, so not a good dog. I learned about this dog. It was on the news, right? This dog went viral. This ad went viral and by the way, this is what, you don't have to tell me because I'm sure it's, you know, weird, but can you just think about all the weird things you did during lockdown, during the pandemic? One of the things that I did that I'm not proud of is I watched the news on TV, like in front of the TV. I wasn't like I didn't read the BBC app or something like that, right? So I saw this on the news, this ad. And yeah, this dog is is also kind of cute, you know, like kind of evil, but also very, very cute. So I thought, well, gosh, wouldn't it be nice to do something so that we could find a nice home for something like Prancer, somebody like Prancer, okay? So I figured I'm going to do that as always by going, of course, to my second favorite place on the internet. Obviously, my first favorite place is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do, my friends, is we have some choices to make. First of all, what build tool do you want to use? I'm going to use Maven, suit yourself, Java or Kotlin. Who's using Java? Groovy. Okay, guess what I'll use? Java. I love Kotlin, I love Groovy, they're all great, but we're going to use Java today. I have some choices down here about what I want to name the project. Friends, I'm amazing with names. Amazing with names. I'm gonna call this service. I'm amazing with names. I get that from my father. My father was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, really, really good with names, amazing with names. So I'm going to call this service, and then we have the decision around what version of Java we'd like to use. Obviously, friends, there are 3 versions here, but only 2 real choices. It's Java 21 or later, right? You could choose this, but you should absolutely never, ever choose this in any context ever, right? It's rude. It's a bad form. It's bad technology, bad decision. So I would never choose this. And obviously, there's a 4th phantom choice here that doesn't exist and never will, Java 8, right? And that is a completely irrelevant choice as well. I would never choose Java 8. First of all, because you have to use Java 17 or later as a technical baseline for Spring Framework 6 and Spring Boot 3, but also because Java 8 ain't great, right? Remember, Java 21 is, in my estimation, one of the most single important releases of Java ever, and it includes a number of amazing features. So it is an obviously good choice, and anything later than that is a good choice. Remember, Java 23 is already out. It's GA. We're on the way, we're on the road to Java 24. And so Java 23 and later, and Java 21 and later, are technically superior in every way. They're faster, they're more performant, more robust, more secure, more operations friendly, more awesome in every way. They're technically superior in every way. They're also morally superior. You won't like the look of sadness in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21 and later. And remember, if that doesn't convince you, if you're not already so persuaded, remember that Java 24, when it comes, mathematically, will be 3 times Java 8, right? It's an amazing release, an amazing release. So, friends, we're going to use Java 21 or later. We have some dependencies. We're going to add the GraalVM native image support. We'll add the web support. We're going to add a SQL database. I could use Postgres, but I want to use some AI, so we're going to use some vector store capabilities. So I'll bring in Postgres with vector store. I'm going to, where'd my IDE just took the vacation? Okay, coming back. Hold on. Whoa. Oh, here we go. No, it's there. We're going to add the vector store, and we're going to add OpenAI. Here we go. Add that. And we're going to add the... Why? Oh. Oh, that's what happened. It's how bizarre. Okay, I think I crossed my legs, and the HDMI cable got loose, so I'm going to cross my legs the other way. So I don't knock it out again by accident. Or better yet, maybe I'll just do this. Who knows? Okay, so I've got OpenAI, got the PG vector store, I got the web support, GraalVM. I want my code to be scalable as a code base, so I'll bring in Spring Modularity, and of course I need a data access framework, so I'll bring in Spring Data JDBC. Okay, so I'll bring in those dependencies. I'll hit enter, and I'm going to go to the command line here and go to my code base. I've got the zip file here. I'm going to open this up in my IDE. It doesn't matter what IDE you're using, so long as it supports the versions of Java and the build tool of your choice. Now, can you all see that in the back? No, you can. It's really small. Okay, let's see. Here we go. Can you see that in the back? Okay, so this is a data-centric application. I've already got a database running. So what I'm going to do is I'm going to specify that connectivity information right here, okay? PostgreSQL, localhost, my database, and we'll do the URL. The username is my user, and the password equals secret, okay? There we go. I'm going to click on this little button here and have it generate a connection for me. I'll hit test connection, hit apply, hit OK, go over here, go to that, go to this, refresh, go there, my database, public, tables, and we've got a table called dog. And this table has, as you can imagine, dogs, right? And we can see our pal Prancer. He's right there. His ID is 45. His name is Prancer. He is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin, okay? And at the moment, this dog has no owner, right? The owner column is empty. So we're going to build an application to sort that right out, okay? And in order to do that, we're going to build an application in a module. We're going to build a module, a package, in our code base to support adoptions, okay? So I'll build a new class here, dog adoption controller, okay? First things first, get rid of the word public. I don't need it, and it's a bad default, right? And what I want to do is I want to build an application that has some data, it works with the data. So I'll build a record here. So int ID, string name, string description, and of course the owner, right? And voila. And I'll give it a primary key like so. And I'm using Java records. I love Java records. I just love them so much. They're so good, okay? Big fan. So I'm going to use that. I'm going to add the dog repository as well. Extends a list of CRUD repository, integer dog. There you go. And remember, I'm using Java records here. This is just one of a lot of different features, a number of different features in Java 21 and later called data-oriented programming, okay? And these features taken together, there are sealed types, there's pattern matching, there's smart switch expressions, and of course we have records, right? So expressions and records. Records, oh yeah. So there we go. So these features are really nice. I'm not going to show them all here, but just trust me, you get in on that. You get to be a part of that by using these features, and they work well together, okay? So our goal now is to support a method to support adoption. And so I'll have the dog ID, and we'll have some JSON that'll come in from the client that tells us the new owner, okay? There's this, and we'll say at path variable, at request body, and there we go, dogs, dog ID, adoptions, voila, okay? And post mapping, dogs, so there you go. Oh, oops, wrong one, that goes over here, I'm sorry. Kind of zoned out there, here we go, post mapping, and voila, okay? And so that's the data. So what we're going to do is we're going to inject the repository there, private final dog repository. We'll inject that in the constructor up here, and we're going to look for the record in the database, like so. And if it's present, then we're going to change the owner field on the dog, okay? So we're going to create a new dog with all the same data, except that the owner will come from the request. So dog.id, dog.name, dog.description, exactly as it was. But we're going to then save it into the database with this new owner field, like so, okay? So voila, okay? And I'm just going to print out adopted this dog, right? New dog. Let's see, here we go. So now I've got that. I'm happy with that. I think that'll probably work. I'm pretty comfortable with that. Let's try this again. So I'll go ahead and start the application up. Okay. And I'm going to go to the command line, and I'll run curl. Okay. -d. And we'll say this and this, and we need to pass in the name of the owner, and it'll be Josh, and X is the post, and then H is the content type, and application, JSON, and then HTTP, localhost, 8080/dogs/45/adoptions, okay? So I hit post, and it says adopted the dog, hooray! Okay, so we go here, dog, and there's the owner. It's been changed. So it worked. I mean, it doesn't feel like a victory because after all, remember, I now have 2 terrible dogs, which is not exactly what you would want. But nonetheless, it worked. That said, this is really, it's a toy, right? This is a trivial example of some data processing. It's not real. And what I mean by that is you're typically going to have, if you do an actual dog adoption, a lot more things involved. You're going to have other services that need to be involved, other agencies, other processes that need to happen before you can actually take possession of a real live animal, right? And so let's imagine that I want to also schedule a visit with the veterinarian, right? The veterinarian is the doctor for dogs, right? So let's build a class to model. You know what had just occurred to me? Wait a minute. A veterinarian is a doctor for dogs, so dog tour. Okay, there we go. Good. And so what we're going to do is this is going to be a service as well, or it could be just a component. And maybe I'll have a, maybe I'll make this public because I need it for a second. Public void checkup int dog ID, and we're going to print out checking up dog number and then dog ID, right? So there we go. There's that. And maybe I want to inject that into my controller. Maybe, maybe now I should have a separate service, right? Maybe I'm doing a little too much inside this controller, but that's okay. Just to keep it simple, we'll just keep everything in here for now. And I'll inject that as well. And down here, I will go down here and I will call this .dogtour.checkup dog ID, and I shall restart, and then we can rerun the same request. Whoop, there we go. What happened? There we go. It ran it, and it says checking up dog ID 45, adopted, blah, blah, blah. Okay? So that's worked. It worked. Of course it worked. It was a demo. It was always going to work. But nonetheless, something feels wrong about it. Something doesn't feel good about this. I've injected one thing that needs to happen into this controller, but I don't depend on the outcome of that. I can launch that checkup, and it needs to happen, but I'm not actually all that concerned with it. And worse, I've now got a so-called God class. I've got too much going on in this controller service thing that I would have to test. It's going to become very difficult to extract out all these collaborating dependencies and test each bit in isolation. And so you want to be very careful of that. I want to decompose these two classes so that I'm not coupled in an unnecessary way, one to the other. So what I want to do instead is maybe I move it in, I use events, right? So what I'm going to do is I'm going to create a new class here called dog adoption event. And this will be a record. And notice that this is a public type. I'm okay with this being public. And and the nice thing about that is I can now go to the dog tour here, and this doesn't need to be public anymore, right? I don't need it because I can communicate in terms of that event. And we will publish this event in the controller, just like before. Did you know that Spring actually has an event bus? This is one of those things that's been there for decades. It's a really nice thing. It's called the application event publisher. So I shall inject that. And we'll say private final application event publisher, voila. And we'll say this dot publisher equals publisher, okay? And down here, I can just say this dot publisher dot publish new dog adoption event, right? Very good. So I'm going to publish that event. It's going to be published over here, and I'll see the results. And this application event publisher is actually from Spring Framework 1.1.1, and I love the history of Spring. How many of you have seen Spring 1.io, History of Spring? You can play the video game at home. I won't do the whole thing here, but it's a little fun, a little journey down the wide and wonderful world of Spring. Anyway, we've got this event publisher, so I can publish an event. Let's go ahead and see what that looks like. We'll go back to our command line, hit run, and then go over here, and it says checked up on the dog and adopted. Okay, so it's working. We have the same exact results in the same order. The thing is, though, I'm using events, and I'm decoupled. One thing doesn't need to know about the other, but we're not entirely decoupled. Because if I publish this event, and over here in this method, I sleep for, let's say, 5 seconds, right? 5. Well, this will now, it's executing by default in the same thread, and the result will be that when I publish the change, it'll actually take 5 seconds to return. This is not good, right? It's actually a simplifying thing. It makes life simpler because they're executing in the same thread. And that's good if you want to be in the same transaction, for example. But it's bad because I have to wait. I don't even know why I'm waiting an extra 5 seconds. I just know that something else is taking 5 seconds, and I don't even know where. I want to be able to decouple that. So I guess I could do something like this. I could use @async, right? And if I wanted it to be in a transaction, I could do @transactional to start a new transaction. And that would all sort of kind of work. But what happens if I pull the power out from the machine before this method has had a chance to finish executing? I now have a system in an invalid state. I've adopted the dog, but I have not scheduled the dog tour visit, right? And so this is not great. What I want to do is have some way to make sure that my code eventually runs. And I can use a nice feature in Spring Modulith. This is a nice feature in Spring Modulith to handle all this. And in order to make it work, I need 2 more properties. So I can say republish outstanding events on restart and Modulith initializing schema. Okay, so I'll go ahead and restart. Everything else is exactly the same. It returns immediately. You can see it says adopting, but now I have to wait 5 seconds. And if I go over here in the meantime, I have this table called event publication. I have a listener ID. I have the event type. I have the serialized event data type. I have the publication date and the completion date, okay? Now notice that if I run this again, refresh, the completion date is now empty. I stop the process. What happened? Uh-oh, completion date is empty, right? I didn't finish executing that handler. It didn't get delivered. This is kind of like the outbox pattern. So what I'm going to do, did I restart it? Yeah, I did. So there you go. It says that. So it restarted, and now the completion date has finished. So it republished the missing message once the application was restarted, right? So I'm guaranteed to process it eventually. So this is the best of both worlds. I can use this nice convention in Spring to publish messages, and if I want to, I can process it and I get guaranteed delivery. But even better, if I have something like Spring integration or Kafka or whatever, or RabbitMQ, I can just add the externalized annotation and specify the destination. And as long as I've got that stuff configured, then Spring Modulith will also publish the message via Kafka or RabbitMQ or wherever for external microservices, right? Remember, the goal here by building modular code is to make it so that when you make a change, the impact of that change is as small as possible. You don't want to disturb other parts of the code base, right? This is the same reason we have microservices, is we want to be very clear about where my code stops and your code begins. And if we make a change, that requires coordination. If we change something that impacts both of us, that requires coordination. You want to limit that coordination. That coordination is what causes organizations to become slower and slower to evolve. It's not the size of the code base, it's the mess that each new feature adds to the code base that causes organizations to have trouble releasing more and more quickly, to make better changes, deliver into production, and so on. So Spring Modulith helps with that. And we can say that our code is now modular because we're only communicating in terms of this event. But how do you know? Like, how do you know if you're doing it right? Well, just write a test, right? So I can go over here and let's ask. We'll say application modules dot of service application dot class. Okay, and I'm going to print out the modules. I can verify the modules, and because Spring Modulith even knows the shape of the modules, I can even document the modules, right? I can say write documentation, and I'm going to run this test while also drinking some water. Okay, and so that's worked. You can see here that if I go down here, it knows logically that I have these different modules, these different things, and it knows that the test is green, and even better, because it knows how my modules are arranged, it can actually document them for us. It generated a nice C4 document here using, this is Simon Brown's amazing C4 component diagram, and now the architecture of the code is diagrammed at the same time, right? So if I change the architecture, so too does the diagram also change, right? So this is a good result, living architecture diagrams. Now, this is good. I think we did a good job. We have modular code. We have, we're able to adopt Prancer, but we're not done, are we? How did I know about Prancer? I saw him on the news, right? How do most people adopt a dog? Hopefully, they don't see the dog on the news, right? It should just be like, oh, I went to the shelter, I found an animal that I like, and I'll take it home. But usually that process involves asking questions that you want to have answered and sort of working through the process, right? So to help people with that process, we're going to build an assistant, okay? So an assistant like this, and this assistant is just going to be a thing that'll help people answer questions. Remember, we're building a service to help people adopt dogs for a fictitious dog adoption agency that we're going to call Pooch Palace, okay? So in order to make this assistant work, we're going to use some AI. I'll bring in the chat client like this, and I'll say builder.build, and here we go, okay? And the chat client is how we talk to our AI models. Spring AI is a very powerful framework for building and working with AI, to do AI engineering. And in order for us to connect to a particular model, in this case, we're going to use OpenAI. You just specify, first of all, your API key. But friends, I've already done this off stage. I exported an environment variable, and I set that up. So forgive me for not leaking my API key. Just trust me, it's already been done. And so we're going to use that now to ask questions of the model with the goal of adopting a dog, right? So let's actually inject that here, chat client, okay? CC, and we're going to say var content equals cc dot prompt do you have any neurotic dogs, right? And then we're going to ask for the call, and we'll get the content back as a string, and we're going to print out the response like so, okay? And then we'll go there, content, voila. Okay, so this is a string, okay? Let's ask it what it thinks. Let's go ahead and Oh, that's the test. Let's run this instead. Okay. And give it a second. Hopefully the Wi-Fi is good. Yep, it's fast. Look at that. It says, I don't have any dogs or pets, but if you're dealing with a neurotic dog, okay, so it's trying to help us. It doesn't understand the question. Like, it's an AI. Why would it have dogs? It doesn't know that it's supposed to be an employee of Pooch Palace. So we need to give it a system prompt, okay? A system prompt helps you determine the tenor, the tone in which you answer questions. So I'm going to take that here, and I'll go back and I'll configure the chat client to have a system prompt. So var system equals this, okay? And we're going to specify that there. We'll say system, and get rid of that, and this, and we'll restart. And it says, you are an AI-powered assistant to help people adopt a dog from the adoption agency with named Pooch Palace with locations in, oh, beg your pardon, Thessaloniki, Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. Information about the dogs available will be presented below. If there's no information, then return a polite response suggesting we don't have any dogs available. And it did. It says, I'm sorry, but we don't have any dogs available for adoption. Please check with Pooch Palace at a later time or contact one of our locations for more up-to-date information. Great. It still hasn't connected us with Prancer, but at least you could think, well, this is a person maybe. They work for the company, and whatever, maybe they cannot bring up the inventory. And by the way, I just used the cat command here to get that prompt. Pro tip, always alias, right? So I also have dog, which does the same thing. So now, I have the prompt there, it's working, but I still haven't integrated my model with my data. My data lives in a SQL database in this table, so that's the dog repository, but I don't want to send all the data in my SQL database to my model. I want to send just the records that could possibly match. So I'm going to support similarity search by adding it into a vector store, okay? And so what I'm going to do is I have to quantize, I have to vectorize all the data in the SQL database. So I'll say repository.findall.foreach.dog, and we're going to create a document, okay, new document, and it's going to have ID colon name colon and description colon, okay, formatted, and it'll be a dog.id, come on, dog.name, dog.description, okay? And we're going to then store that in the vector store, so .add list.of document, okay? Now, obviously, this is a document that deals with dogs, so document, okay? Very good. Now, this is going to work. We'll have it in the vector store, but our model still doesn't know, our chat client doesn't know about that yet. So we need to support we need to tell it to look for it there, to get the data there, and then use that to inform the response. This pattern is called RAG, okay? In order for this to work, by the way, I need to initialize the vector store schema, so I'll do that, and I'll restart the application. So this pattern is called RAG. Remember, I woke up this morning, because remember, we're not using PHP. This isn't like JavaScript. This isn't those other languages. I don't want to waste time or code. I woke up this morning. I said, I want to build a retrieval augmented generation pipeline. I wrote one line of code, and I have a retrieval augmented generation pipeline. What did you do this morning, right? So now, I ask the question, and it says, hey, yes, I have a neurotic dog available for adoption. Prancer is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. If you're interested in learning more about Prancer or other dogs, feel free to ask. Boy, am I, right? So, it's worked. We found our dog. Let's obviously comment out the initialization again. We don't need to initialize everything again twice. But it did work, okay? So now, I kind of like the result, but the problem is that result is a free-form string. I have an API, so maybe I want to turn this into an entity, right? Something that I can use in my API code. So I'll do that here. I'll create a record for that called dog adoption suggestion, and I'll change this to entity, passing that back, and then I'm just going to rerun the same exact program with those changes in place. And wait for a second. Wait for the AI to come back. Wait for it. Take your time. Did I forget to do something? Did I print? Oh, am I not printing it out? If false, the model, is the internet like weird? Hold on. Wait for it. There you go. It says, content, dog adoption suggestion. ID is 45, name is Prancer. Description, a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. Much better. Now we have a Java object that we can use, and I think it's now time to turn our direction towards production. And here, my friends, we have three very important questions that we need to ponder. First of all, is our code efficient? Is our code efficient? Well, of course it's efficient. It's Java, right? Obviously it's efficient. Have you seen this wonderful blog? This blog is from, it's based on a paper that was published, I think in Portugal, actually, not far from here, in 2018, before the COVID pandemic, or BC. And this blog asked the question, which programming languages use the least electricity? And you can see some interesting results here. I think this is pretty darned interesting here. First of all, here are the normalized global results for energy, time, and memory. And I think the results are pretty interesting, right? If you look at this, you can see that C is the most energy efficient for machines, not for people. Definitely not for people. Rust, doing quite good. Zero cost abstractions, well done. C++, tooey, disgusting. Disgusting. Moving on. Ada, no one cares. And then Java. And Java, by the way, virtual machine, right? V for virtual, not compiled. One wonders, then, what would happen if Java were compiled? That's called foreshadowing, my friends. It's foreshadowing. We're going to see that later. Just hold on, okay? Keep that in the back of your head. So Java is 1.98. We can call that 2.0. Just round up, okay? Then we have these other languages, all of which are pretty interesting. You've got, Swift, and C# is Pi, which is cool, right? That's nice. Go away. You've got JavaScript and TypeScript. How is this so much worse than this? 4 or 5 times. What is going on with this? TypeScript, JavaScript, TypeScript, JavaScript, type, Java. What in the? This is. I thought this compiled into that, and then much better. JRuby is Ruby written in Java. And Ruby is Ruby written in C. And you can see that very clearly the version in Java is almost a third more energy efficient. And then we have this. And I'm going to round up. Let's just call that 76. I'm not very good at math, but you know who is really good at math? Freaking Python. So let's do that, right? Python 76 divided by 2 is 38. So 38 times less energy efficient than the JVM. That's not great. That's worse than Bitcoin, right? That's really bad. That's a bad result. Okay, so we now have an answer to that first question. Yes, our code is efficient. Is it scalable? Well, friends, to the extent that we can solve problems quickly, of course it's scalable. But remember, a lot of things are beyond our control, right? The faster we can do work and then start more work, the faster we can handle more requests. That's great. But the work that we do, often, almost all the time, right? It's going to happen on threads. And a lot of times, the speed at which we can process that work is beyond our control. It's somebody else causing us to wait. That's like a network service, a database, an open AI or a model, LLM model, something. We're going to cause us to wait. And this creates a bit of a problem because we're going to have, a lot of waiting that happens. And if we have a limited number of threads, then that is a bottleneck for our scalability. Up until recently, right? We have now virtual threads. Virtual threads are amazing. So I'm going to create a simple example that I stole. I'm stealing this from my colleague. Her name is Cora E. Berkeley. She's a genius, okay? And you can follow her on Twitter, and just really, really smart person. So I'm going to take this example. It's a controller, and what I'm going to do is I'm going to create a REST request to an actual network service here, okay? And I'm going to call this delay, and here we go. We're going to say this .http.get.uri https http-bin.org delay /5. So I'm going to artificially block for 5 seconds. That service, when you call it, it doesn't return a response for as many seconds as you specify in the URL. So there, I'm going to wait 5 seconds before I get a response. Okay, and so that's going to run inside of a Tomcat. That's going to run inside of an HTTP servlet engine. And in order to really sort of force my computer to share, I'm going to limit the number of threads here. Okay, so let's go ahead and I need to also define the bean for the REST client. Let's do that here. So I'll say bean REST client. Okay, return, and I'll say REST client dot builder, okay, and we'll say builder dot build, okay. And now I'm going to restart this, and what I'm going to do is I'm going to do some load testing here. I'll say, hey, minus 40. So that's 40 total requests. Not very many, but just to kind of prove the point here. Localhost 8080 / delay, okay? And I haven't enabled virtual threads here. Oops, I have to do localhost 8080 / delay. Oh, I actually did that, didn't I? Oh, yeah, it's okay. Here we go. I got to fix the number of concurrent requests. Here we go. Come on. There you go. So that's going to run 40 requests total, 20 concurrent. And by the way, the reason I forced contention by limiting this to 20 is because I have an amazing machine. My computer is freaking amazing. But to be fair, so is yours. Anything in the last 10, 20 years is an amazing machine. When I first started working in IT in 2002, we would get these giant $20,000 servers. They'd come to our office. We'd have to install a Solaris or Linux or whatever. And then that's what we had to do. That's what our job was. But first we would install Windows and play Doom. And the reason we did this is because where else would you get the chance to run a game on a computer that amazing? The computers that we had in prod were amazing. The computers we had in the office were terrible. Now it's the exact opposite. These machines are freaking amazing. I can run Microsoft Teams and Slack at the same time. At the same time. Scientists didn't think this was possible, and I can do it now, all right? So I have to force it to be a little bit weaker, okay? So there's the result without virtual threads, okay? Let's take that. And now we need to migrate. We need to refactor our code to take advantage of virtual threads. This won't be easy, but, you know, okay, it's done. So we're going to go ahead and restart. And now, go back here, make another call, and we'll just wait for those responses to come back. We're going to call this yuck, okay? And get rid of that, and we're going to call the ones that come back with virtual threads yay, okay? There's this. So the results, I think they kind of speak for themselves, don't they, right? I mean, if you look at this, the total time was 11 seconds with virtual threads. Without them, it was 22 seconds, so literally twice as slow. The slowest took 16 seconds. Remember, it's supposed to take about 5 seconds. A little bit more than 5 seconds is acceptable. And that's what you see in both of them, 5.1, 5.1. But the slowest took 6.3 here with virtual threads and 16. So 3 times slower than with virtual threads. The request per second, 3.3 versus 1.8. The average, 8.9 versus 5.6. Obviously, virtual threads are amazing. And by the way, this is the very first time where we as Java people can talk about how scalable our code is and it's less verbose than the other languages. Enjoy this moment. We almost never get it's never the case where Java is as good at something else and it takes less code to do it. But we have it now, right? All those people with their async awaits and their suspend functions, this is what it feels like to be in that wonderful limelight just for a minute. Just enjoy this. It's not going to happen again. Just enjoy it, okay? So this is great. So our code is objectively scalable, right? Much, much better result. No code, no waste. Great. So what about the third one? Is our code fast? Well, my friends, of course it's fast. We're using Java, and Java is objectively fast. How many of you have seen 1BRC, the 1 billion row challenge? Gunnar Morling asked people to submit a program that measured some statistics based on some weather station telemetry data. 1 billion rows of weather station telemetry data. And it's about 13 gigabytes of text. How long do you think it took to process? If you read this already, don't answer. But how long do you think it took to process the results? You hit enter, read 13 gigs of text, do some statistics, print out the results, and then exit. How fast? 2 minutes? 2 seconds? Okay. I've heard people tell me 5 minutes, 15 minutes, 20. The actual answer is 1.5 seconds, right? 1.5 seconds. Where is this one? Up. Here we go. 1.5 seconds, 0.58 seconds, 1.6 seconds, 1.8 seconds. So the first three, it's worth noting, are all using GraalVM, okay? But the third one is not, and it's still very impressive. So GraalVM obviously is a very good idea, but it does require that we tell it about any dynamic behavior. So here, we're using this and we're getting some reflection in the results that come back. So what I'm going to do is I'll tell GraalVM, that we're going to do this reflection by registering that type like so. And then we're going to kick off a native image compilation. So here we go. Skip tests, p, native, compile. And we're just going to let that run and do its thing. Now, friends, this will take a little while. This takes a little while. And that's my least favorite part of this feature, of this technology, is that it just takes a long time. And it reminds me of this wonderful XKCD cartoon that asked the question, what is the #1 excuse for slacking off? And these two idiots are on their chairs, goofing off, and the boss says, hey, get back to work, compiling. Oh, okay, carry on. I get this joke now. I thought this was for the C++ people, but it's actually us now too, right? I don't understand it, but it's actually happening. And I get really bored waiting for these native compilations. It just takes forever. And it reminds me of these long elevators, or I guess you'd call them lifts, right? I don't know which version of the word you're using here. Lifts in the English versus the American English. Elevators in the States have these really long times that just take forever, and you hear music. And the music doesn't stop. And the whole point of the music is to keep you distracted so you don't notice how long you're stuck in this lift waiting to get to your floor. They call it elevator music. And I thought, wouldn't it be great if everybody could hear elevator music when they did these native image compilations? So I went to Oracle. And I said, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do, I really do. They're doing amazing things. I got some great responses. This one is some copyrighted music I can't play, but it's a great response. I would add that using beeps in general, not only for native image, helped me to reduce development time. That's a great point. It's like a microwave. You kick off the compile, and then a minute later, ding, it's done, right? You can come back to your code. Somebody else said, this is Dr. Fabio Niephaus on the GraalVM team at Oracle Labs. He said, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Anyway, I have prototyped the -- long mode. So, what this would do is, X. What this would do is you run the native image compiler, native image, -- long mode. You'd hear music. Obviously, there's no music. It's a picture, but that's the whole point. You'd hear music. Now you're confused. Who's doing this to you? It says music brought to you by Josh Long. That's me. And then you still want something to look at, so it'll print that out, right? I think that would be a great feature and a great addition to the compiler. I don't know when they're going to merge it, but hopefully soon. What were we talking about? Oh, right, the compilation. Yes. So if we go here, here's our binary. Kick off the binary. The port is already in use. Go over here. Go there, start again, okay? 0.2 seconds, very nice. Go over here, grab the process identifier, and we can measure the RAM using the resonant set size. This is measured in kilobytes, so divide by 1,000, and it's 170 megabytes for an application that has AI, observability, a web stack, a data access technology, and so much more. And it's modular as can be. We live an amazing time, my friends. There has never been a better time to be a Java and Spring developer. And of course, now I have 2 terrible dogs. Thank you for coming. Have a great day. Bye-bye.